Welcome to our session today, GitOps as a Service. My name is Andrew Block. I'm a distinguished architect from Red Hat. I specialize in a number of different areas, everything from cloud-native architectures, CI/CD, GitOps, and security. I'm an open source maintainer on the Helm project, as well as ORAS, which is an OCI registries as storage. And also, I'm an author. I've written 2 books in the cloud-native space, one on Kubernetes secrets and Helm.
My name is Gerald Nunn. I am the OpenShift GitOps Technical Marketing Manager for Red Hat. I've been with Red Hat since 2016. Before my new role, which I started in January, I was a solution architect for many years. I live not too far from here, near Victoria, British Columbia, with my wife, son, and 3 very slightly annoying cats.
We'll try to stay away from being cat-friendly. So today we're going to talk about a number of different areas. First of all, what is this concept of GitOps as a service? And then all the considerations that you need to think about whether you want to choose to run a GitOps as a service, whether the buying or the building one of your own. Some common principles and personas that come with GitOps as a service, as well as some common service models. Considerations for isolating workloads, as well as some deployment methods, and of course, everyone's favorite, standards. So GitOps as a service. So everything these days is being offered as a service. You go to AWS, you go to Azure, you go to Google, everything's a service, databases, you name it. Now, GitOps can also be run as a service. And the question is, do you want to or do you not want to? And it comes down to the question of, do you want to buy a managed service of your own or build one from yourself? And in addition to that, you need to think about all the trade-offs when it comes to building versus buying. Building gives you that flexibility. You can do whatever you want to your heart's content. However, it does require you to have quite a bit more technical acumen than if you just go ahead and click a button. Something's just available for you. Now, if you do go down that route of clicking the button and getting GitOps as a service or a managed service offering, yes, you can spin up resources relatively easily, but unfortunately, you're kind of baked into what that service provides. You don't have as much flexibility to customize it. And that's really some of the trade-offs you need to think about when determining if you want to go forward to use a service that's provided for you, doing the whole buying option, or building it one yourself. As being a technical person, I always say, I can do it, but not everyone wants to be able to have that opportunity to build everything and maintain it yourself. So in the GitOps world, there are in many cases 2 different personas we need to cater to. One of them is your platform operations team. They're going to be the one that manages Kubernetes clusters, doles those clusters out to individual application teams. And then you have your developers. These are the ones that typically are your application users. Everyone from I'm a core developer and that's all I do is code and I might play with Kubernetes, all the way to those who are doing testing, CI/CD, and everything, but not at a cluster level. So what are some of these responsibilities between these 2 users? Well, developers, as I mentioned, will typically be just responsible for maintaining applications. They know how to deploy applications. They know what an application is. They may be familiar with Kubernetes. They typically work within individual namespaces, one or multiple individual namespaces. They do not have a viewpoint of an entire Kubernetes cluster. And most importantly, because they only have a set number of namespaces that they manage, they typically have less permissions at a cluster level. They're not able to see everything. They can just see their own little slice of the world. Versus the platform team, they're responsible for everything. They can go ahead and see all the different namespaces on the cluster. They can see who's out there, what resources are available, be able to define new custom resource definitions, everything to their heart's content. And then what they need to do is they need to consider the balance between development teams and what they need to do from a platform management capability. And that's really the 2 different personas that we typically see when working with a GitOps as a service type paradigm. So what are some of the common paradigms that we do see when it comes to GitOps in general? Number 1, if you're just getting into GitOps, the first thing you're going to do is deploy the actual application, whether it be Flux, whether it be Argo, whether it be not even Kubernetes whatsoever. If you want to actually use GitOps in a different context, as we talked about earlier this morning, GitOps is not only Kubernetes. It's really anything that can reconcile state. But in most cases, especially for this talk, we're going to talk in the Kubernetes world. GitOps, bring your own GitOps. I want to go ahead and install it and maintain it myself. Developer does it, great. The other one is going to be when you have a platform install and manage GitOps solution, but then you have your developers who are going to be able to manage the day-to-day life. Basically, just doling out this from a application or from a platform standpoint, and then giving somewhat of an autonomy to your development teams. But once again, you still give them a small set of the world that they can then manage themselves. And then finally, the last one is where you have the platform owns, the platform manages everything. It just goes ahead and it has the entire ecosystem that it has to deal with. As someone who lives in the platform side, it's a lot to take on, I'm not going to lie. So these last two boxes here, these two paradigms, are what we think of as GitOps as a service. It's not going to be the bring your own GitOps solution. It's going to be the one that you're going to have some team manage and then provides to others, or at least be able to use it for other use cases. So some of the challenges regarding this model is how much complexity that you need to provide to both your development teams and your platform teams. Now, when you have a bring your own GitOps solution, you're giving more onus and more technical acumen that's needed to be made on the developer side of that world. They need, as I mentioned earlier, they need to go ahead and know how to manage a GitOps server. In many cases, developers know how to just manage applications. They barely even know what GitOps is. You have to teach them. You have to go ahead and say, okay, I can go ahead and maybe deploy on day one. How do they manage actual platform infrastructures? From a platform perspective, there's the day two care and feeding of your server. There's going to be potentially backup restore, operationalizing, notification, monitoring, some things that you don't think about in day one, but now it becomes a developer problem, where all they care about is writing code in most cases. Versus a platform side, if you go ahead and you give them all the power to manage everything, you're going ahead and putting all the onus on them to be able to then manage everything. They have full control, but once again, they need to then manage every aspect themselves. And as someone who works with a lot of application teams, I'm sorry to say, you're needy. You're really needy. I want this, I want that, especially when you have cluster level resources like CRDs. I need the CRD, otherwise my app's not going to work, I promise. So really, if you want to choose between one of these different service models, it depends on where you are within your organization. So bringing on GitOps is great when you have maybe a small number of application teams. Developers are very 10x. They can do everything. They don't need a lot of care and feeding from an application team. Maybe you have really small clusters. If you want to use more of a platform managed side of the world, this is when you start looking at developers who are just getting into Kubernetes. They may not be very familiar with Kubernetes. Versus you then need to have more of the platform team manage more of the day-to-day feed of the GitOps solution at all. And then finally, platform install and platform manage is when you have really developers who have no Kubernetes experience, but you need to have a high, you need to think about security, because security, as you know, and half the talks either today, but also especially when I was at GitOps, KubeCon 2 weeks ago. Guys, is that only 2 weeks ago? Oh, geez. All the talk was security. Security. We're going to talk about security in a moment, but that's where it's really important when you think about running a GitOps at scale. You understand that security is baked in. It's fundamental. If you don't think about it, you're going to actually hurt yourself in the long run. So, as I mentioned, isolation. I know. I think I went over your slides.
Yeah. I'm going, Andy's doing a great job of covering my slides.
I'm sorry about that.
No, that's all right. Stuff happens. And you were on a roll. I didn't want to stop you. It's like getting in front of a moving train. I'm not Superman. I'm not going to stand in front of that train when it's on a roll.
I'm going to just tackle isolation, then you can just power through it.
Sounds good.
Apologize about that. So isolation, as I mentioned, security is incredibly important. Security in all aspects is, and I actually had a talk on this at GitOpsCon 2 years ago, give or take, around securing GitOps. It depends. It depends on your organization and your team structure. Do you want to be able, are you able to satisfy not only your organization requirements, because many different organizations have very different requirements, everything from regulatory compliance to just different principles and practices within your own security teams. And then once you look beyond the organizational requirements, how good are your individual application teams? Do they trust each other? Can you trust them? What is the autonomy between them? How much technical acumen do they have? That's something you need to think about when you want to isolate workloads, because if you have application teams who have no idea about Kubernetes, are you going to really give them access to kubectl delete things in different resources? That's just a recipe for very, very bad choosings. There are multiple isolation models that you can consider. I'm going to turn this one over to you for the isolation model.
Sure, why not?
Yeah.
So in terms of isolation, there are a variety of things. And just to build on what Andrew was saying as well, it's not only just about security, it's also about misconfiguration and human mishaps that happen. Who here has accidentally deleted a database in production? Just me? Am I the only one? You know, people make mistakes. It's not unusual for two people to stomp on each other or interact with each other in ways you don't intend in a system, and isolation is important, along with security, to prevent those mishaps. So in terms of isolation models from a full isolation perspective, everybody gets their own GitOps instance, right? As Oprah would say, here's a GitOps instance for you, here's a GitOps instance for you, off you go to the races. But that can be somewhat expensive. So the next model really that we see, it's probably the most common one, is partial isolation around boundaries. These can be team boundaries, these can be situational boundaries, i.e. different use cases where the different instances are going to react. And then finally, no isolation, everybody's just sharing the same instance and off they go to the races. So you look at these different isolation models, you can see that there's a relationship between the safety that's being applied with that isolation model, as well as the resource utilization that's being used. And by resource utilization, I'm not just referring to memory, compute type resources, but also the human resources that are involved in terms of managing it, because more isolation means more instances, means more things that people need to manage and maintain. So as you increase the amount of isolation that you have, you increase the amount of safety that you have, both from a security and a mishap perspective, but you also increase the amount of resources that are going to be used, right? Just curious here if anybody's operated Kubernetes cluster. Anybody done Jenkins on Kubernetes? And you've probably seen how many resources handing out a Jenkins instance to everybody takes, right? It's the same idea.
Our sustainability friends would not be happy, but that's all running Jenkins at scale.
Yeah, exactly. So that leads us to a logical topology. So from a logical topology's point of view, this is kind of the three different topologies we typically see. The no isolation is everybody sharing a single GitOps instance in a cluster, both from the cluster configuration use case and the team use case. So the cluster configuration use case is somewhat special because in order to configure that cluster, typically I'm going to need either cluster admin or near cluster admin type privileges in order to do that configuration. And I'm going to share that same instance with teams that are deploying applications. So for the minor security guy that's in me, the little security guy, because I'm not a big security guy, the little security guy, I'm a developer, that gives me a bit of the heebie-jeebies, right? Just the fact that if something goes wrong in terms of how I've configured the RBAC and the permissions in my GitOps instance, somebody could do something on that cluster that they shouldn't be doing. The partial isolation is really designed to address that, where we separate it out by use case. The cluster configuration runs in its own GitOps instance with its own set of privileges, and the teams get their own GitOps instance, but with a much reduced level of permissions, right? They can operate in certain namespaces, they can perform operations on namespace scoped resources, but they can't do really anything at the cluster level. Now, in situations where you need maximum isolations, maybe you're in an industry that has high regulatory requirements, maybe you don't trust your teams aren't particularly technically sophisticated, and you're worrying about different teams stomping on each other and even inadvertently, you can break them out into completely separate resources and manage things that way as well. Okay, so that's the logical topologies, but there's also the physical topologies that come into play and how we deploy this. So we saw a little bit of this with Dan, I think earlier, where he had his 4 topologies. For me, I like looking at this as 2 topologies. And for me, I really go by intent. What is your intent when you're defining your topologies? Is your intent centralized, i.e. I'm going to have a centralized GitOps instance that's managing a bunch of different clusters? Or is my intent distributed, where I'm going to have separate individual GitOps instances running on each individual cluster and managing it that way? So centralized, as Dan alluded in his presentation, it's great from the point of view you get that single pane of glass. I can see what's going on across my whole fleet, no problem at all. The downside of it is it's also a big fat single point of failure. If you lose that cluster or you lose that instance or the networking goes out to it, you've lost your manageability across all your different clusters. Distributed, on the other hand, addresses that single point of failure. It solves that problem, but you lose that single pane of glass. Now, like I said, I define these by intent, but there are variations, right? There's a lot of different ways to do your topology model. So a common one that we see, I like to call it the Intuit model, because they were the ones I first saw it a couple of years ago, I think, at one of the ArgoCon 2020, I think it was, where they outlined how they do this. And they essentially, I look at this as more of a variant of centralized. You could maybe argue it's a variant of distributed. I'm happy to argue it over a beer with you at the pub or something afterwards. But for me, it's centralized because it's centralizing access based on a different boundary, not the cluster boundary, but the team boundary, right? So I'm going to have that single instance of GitOps that's running. A team can see across the different clusters, like say a non-prod cluster and a prod cluster, see their applications, get that single pane of glass, but I avoid that single point of failure in the sense that if team A loses their instance, it doesn't impact team B or team C. Now, if these are all running on a central hub cluster and I lose the hub cluster, I've still blown up everything. But that's really another way that people tackle that. And the other topology we often see is the control plane topology, and Dan alluded to this as well in his presentation, where essentially you have a hub management type of cluster that's running, it has something that's running on it, and it is managing your GitOps across that fleet. This can be a distributed architecture, as I've got it pictured here, where you've got GitOps running on all the different hub clusters, and this is my preferred architecture for hub, but you could also have a hub that's using a centralized kind of model, but providing some extra capabilities over the normal centralized model as well. The nice thing with the hub is that when you're doing this distributed, it avoids that single point of failure. Yes, if I lose my hub, I lose some manageability in the sense that I can't make change, but those instances that are running on all of those other clusters are running just fine. They're managing it, keeping things in sync. Everybody's hunky-dory. So from a topology's recommendations point of view, I am a fan of not using the same GitOps instance for cluster configuration as for teams. I like keeping those two use cases separate and running them in separate instances for the reasons I gave earlier. But having said that, choose a topology that works best for you. Every organization is different. Every organization has different requirements. There's not a right answer that fits everybody. So pick the thing that's going to work great for your particular use case that you're trying to solve. Do not have a separate GitOps instance for each and every application. Don't go the Jenkins model where you're handing them out like candy and just chewing up resources and require more management. Align the number of instances that you need along your team trust boundaries, right? So if you have different teams that work well together, they're part of the same or broader organization, that's an opportunity to kind of aggregate them into a single instance. And then finally, and Dan had this, I think, earlier in this slide too, use GitOps to deliver your GitOps. That's what it's there for, right? Don't manually try to provision all these GitOps instances yourself and manage them. Have a central GitOps somewhere, Argo of Argos, other tools like OCM that we saw earlier. Push those out and manage those for you.
Yep. So when we talk about all these different recommendations and all these different paradigms, where does that lead us? How do we actually do this within an enterprise organization? So what I do and what Gerald also looks into is, where do you start? You start with some industry accepted principles. A good one is the principles that are emphasized by the Open GitOps practice, because they're a good North Star to begin with. Everything from making sure your manifests are versioned, make sure they're declarable, make sure they're constantly reconciling, all of that. That's a great place to start. And then on top of that, you're going to have your organizational constraints. Everything that you need to comply with, whether it be regulatory compliance, whether it be just, I need to make sure that every 5th Friday of the year we do X, Y, and Z. Inject those in. And then finally, you combine some of the best concepts from the community, some ones that are out there in terms of how we manage GitOps at scale, combine it with your organizational constraints. Those become the established processes that you can implement within your own organization. You bring these together and you'll be able to then refine and look how they'll actually work, because no one gets it right. Nobody gets it right. A lot of us, we're just guessing. I'll be frank, we're guessing. But that's where you start with. Do you think we did GitOps perfectly the first time? No, of course not. I work, and Gerald work with organizations across the globe, and we can tell you that they ask us, how do we run GitOps? And we'd say, here's where you start, but it's a journey. We'll come on the journey together and learn. And then what I always recommend is after you learn, share it. Because you're guaranteed you're not going to be the only one that runs into the same problems and challenges. That's what the open source community is just meant for. So, as I mentioned, there is no best practice. As an architect, people ask, oh, what's your best practice? I'm like, I don't know. I'm just a guy. Same thing. Number two, Conway's law is always going to prevail. Your GitOps processes are always going to be a reflection of your organization. That's why we brought in number two as really, it is going to be still part of it. And just know that that's why every use case is different, because you have to sprinkle in those organizational constraints. And then finally, kind of harkening back to the open GitOps practice, make sure these don't become paper standards. Make sure you document them, make sure they're versioned, make sure they're well established and declarative so others will know about it. It's like if you have a Jenkins server sitting underneath your desk. It's just there. It's not going to be a centrally managed system. No one knows about it. That's why you have, what is it called? It's where you're kind of running your own thing. There's a name for it. I'll come up with it later. But anyways, make sure you comply to these standards and then be able to actually be successful in your GitOps journey. And then, Joe.
So one of the big, there we go, sorry. One of the big ones that people get hung up on is repository and directory standards, and I'm not here today to kind of lay out to you the one, 12 commandment type style stone, here's my standards, off you go to the races, because again, there's no one standard that works for everybody, but a lot of organizations when they're starting with GitOps and they're trying to get GitOps as a service going, get really hung up on what is our standards, how are we going to do it, and I think it's really important to look at your organization's operations model, right? So if you're a traditional enterprise, and you have a traditional developer team and a traditional ops team, and the ops team does things separate from the developer team, and they control certain instances that the developer team never sees, never has any access to. That's going to be a very different model in terms of how you set things up than a fully matrix DevOps team where the devs and ops are working together in a single team, deploying the application across all different environments. Avoid analysis paralysis is another common one I see at a lot of our customers, where it just goes around in a rabbit hole or a big circle in terms of trying to figure out what their standard is. Start small and start high level. You don't need to lay out your directory repo structures to the nth degree or the ninth level of traversal. Here's my high level standard. We're going to go with that. We're going to start with that. We're going to see how it works. And then be agile. Iterate, iterate, iterate. Don't be afraid of change. Standards, even though the name kind of implies that it's not something that changes, these change. And it's okay that they change. As you learn, as you understand your organization's needs and requirements, it's very natural to evolve your standards in order to better adapt to the organization's needs and where they're going. Achieving consensus with development teams. So if you're a platform team, you're trying to put in a GitOps standards. One of the challenges you might have is you've got 10, 20, 30 different development teams, and they may not agree on what those standards are, right? So seek input from those developer teams. They will have a lot of good ideas that will have an impact on those standards and be useful, but do not get into an endless loop of discussion with the teams in terms of what those standards should be. At some point in time, a decision has to be made and everybody has to go forward with it. And that's really where management buy-in is critical to break those log jams and move forward. So you really need to have management on board and in line with you in order to be able to make those decisions and make things happen.
And then finally, it's 2023. I'd be amiss if I didn't include platform engineering in any talk these days. It's like all we're hearing is platform engineering. Now, there is a good alignment between platform engineering and GitOps as a service. In many cases, they're going to be very complementary to each other. Both attempt to standardize and enable developer productivity, because you want to make it easier for developers to build and do good things. GitOps has so many benefits, and being able to then provide that and streamline how you deliver applications all the way towards production. Now, I'm going to be honest. In many cases, a platform engineering team at one point ran a GitOps as a service platform, because platform engineering is just yet another extension of what GitOps as a service can provide. So especially in large organizations, to be able to kind of, remember, GitOps is just one aspect of delivering applications to production. It's just one of the services that you would then hook into platform engineering. So being able to have developers be able to easily consume resources that are provided by a GitOps as a service capability is just one yet other component of a golden path that makes it easier for them to get to production. So we have a number of different resources here. Joe's going to walk through the resources.
So these are, hello? Yeah, there we go. So these are just some resources you may find useful. Some of these were referenced for these slides. Acuity did a great blog on Argo CD and how many instances you need if you're using Argo. And Flux as well has a great section in their Git repo in terms of doing multi-tenancy, directory structures, and things that come from that perspective. For repositories and directory structures, there's a lot of prior art that you can look at and investigate. The Argo CD Autopilot comes to mind, allows you to bootstrap projects and get them up and running quite easily and quickly. Flux as well documents their recommended repository structures if you're on the Flux path. Because I'm doing the presentation, I reserve the right to promote my own standards, so I've got a link in there for those as well. Take them for what they're worth. The other thing that comes up for us a lot, being us both from Red Hat, and we're using Argo CD every day from our customers, is how do I manage RBAC for my tenants, i.e. the developers that are leveraging that. There's a great blog that one of our colleagues wrote on how to do RBAC in Argo CD and shows you exactly how to configure your RBAC for the different tenants to achieve the goals that most platform teams, I think, are looking for in terms of the isolation and accessibility that they're providing to the platform. So that brings us to the end.
Yeah.
Any questions?
If you don't have any now, Gerald and I can certainly address them afterwards. We're not going anywhere yet. Yeah.
Hi. So when you give your teams or your developers a GitOps environment, do they manage it themselves? So do they create a PR against the central GitOps repository? And they themselves?
What typically happens, especially in a lot of organizations I work with, is there's going to be an ITSM, like a ServiceNows, that provides them access. It basically just makes a commit to a more centralized GitOps as a service repository, which then makes whatever GitOps solution you have available to them, and then they manage it from then.
Yeah, it really goes back to those service models though again, right?
Yeah.
There's different levels of service models, and it really depends on what you want to offer. So if you want to offer the service to the point of view where it's like application, developers just say, here's my set of manifests, or even here's my source code, and you take care of it all, that's one level of service. Another level of service is more what you're alluding to is that here's a GitOps instance for you to use and you can manage it. Now, whether that management happens through PRs or they directly manage it, again, it's kind of up to you to figure out from a thing that works for you from a service perspective. A lot of the factors that go into that is, are my developers sophisticated enough to manage it? And platform team-wise, do I have resources to do the full-blown GitOps as a service? Do I have the ability and bandwidth to create that solution versus maybe something that's a little further to the left, right, in terms of that spectrum?
Yeah, thank you.
Absolutely. Anyone else? Awesome. Thanks a lot, everyone.
Thank you.